How's it going, ladies and gentlemen? Today we're going to talk about parallelograms, and more specifically, we're going to talk about the sides, angles, and diagonals and their properties of a parallelogram. And I'm also going to show you how to use them. So let's get started with some review, some stuff we talked about the other day, which is the quadrilateral sum theorem. And the quadrilateral sum theorem says when you add up four angles in any quadrilateral, the sum will always be 360 degrees. So that means if I take angle A plus B plus C plus D and add these all up, they should equal 360. So let's use this property, this theorem. So we're going to do example A and solve for x. So quadrilateral sum theorem says take angle A, add it to angle B in this example, plus angle C plus angle D and it should all add up to 360 degrees. So let's try that. So angle A, the measure for angle A is 3x plus 4. The next measure we have for angle B is going to be 75. Angle C is 6x. And angle D is 2x plus 6. All equal to 360 degrees. Now our job is to solve for x, so that means we got to use, since we have an equation, we're going to use the steps of im2. Okay? So to do that, we're going to do step D, which stands for distribute. If you notice, I have no parentheses here. There's nothing to distribute. Next is C, stands for combine like terms. If you look on the left side of this equation, I have a bunch of like terms I need to combine. So let's do that. We're going to combine all the x variables together. So that's going to be 3x, 6x, and 2x. And if you add that up, 3x plus 6x, that's 9x plus 2 more x, that gives me 11x. Now I'm going to add up all the constants, the numbers without variables. So 4, 75, and 6. If you do that correctly, 75 plus 4 is 79, 79 plus 6 is going to give you positive 85, and then we simply bring down the 360. Now, we go on to the next part in DC-MAM. The M stands for move variables together on different sides of the equal sign. Since we only have one variable on the left side, we do not have to do this step. So we move on to A. A stands for add or subtract for the guy we're trying to solve for. So we need to get x by itself, so we need to add or subtract something to the other side. In this case, we're going to subtract 85. Okay, so we get 11x equals 275. And then the last steps for solving is M. We're going to multiply or divide something to get x by itself. So that means we got to divide away the 11 to both sides. And if we do that, we get x equal to 25. So we have just solved for x. All right, so some of the properties of a parallelogram. The first one we're going to talk about is if a quadrilateral, a four-sided shape, is a parallelogram, then its opposite sides are congruent. And again, remember, congruent just means equal in measure. Okay? So that means PQ is going to be equal in measure or congruent to SR. And SP will be congruent to RQ. So how do I use that? Well, it's pretty simple. So let's do example BCDA. Okay, so in BCDA, we know it's a parallelogram. Since it's a parallelogram, we can use this property. So we now know opposite sides are congruent. So that means, how do I figure this out to solve for x and y? Simple. We take opposite sides. Since they're congruent, that means we could put them equal to each other. So I'm going to do x squared equal to 9. And now I'm going to solve for x. So a little review from im2. How do I get rid of something with a power of 2? How do I get x by itself? We are going to square root both sides. And square rooting both sides will cancel out the square root and the power of 2, and we're left with x equals to 3. We have just solved for x. Okay, now to solve for y, we're going to look for, again, opposite sides with y. So 7y and 5y plus 2, they are opposite. We could set them equal to each other. So let's do that. 7y equals to 5y plus 2. And then we solve for y. So again, you could use the steps of DC, ma'am. I'm just going to go ahead and work it out. I need to get the y's together, so I'm going to move the 5y over here. That leaves me with 2y equal to 2. And to solve, I'm going to divide both sides by 2 here. And y is going to equal 1. Okay, so to sum up this property, anytime you have a parallelogram, you could set opposite sides equal to each other to create an equation, just like I did here. Moving on to the second parallelogram. And if a quadrilateral is a parallelogram, then its opposite angles are congruent. So almost the same thing as the previous property, but now we're talking about angles. So we then could look here and say angle P, which is this measure here, is congruent to angle R, which is this angle here. And then opposite angle S is Q. So angle Q is congruent to angle S. And these little arcs mean congruent angles. So matching arcs are congruent angles. So let's go ahead and practice this, given the following example. So just like we did above, if we have opposite angles in a parallelogram, we can set them equal to each other. So I'm going to take angle 60 and put it equal to its opposite angle, which is 2x. So 60 is going to equal 2x. And now I can solve for x. So I'm going to divide both sides by 2. And x is going to equal 30. 30 for x. Okay, so we took care of the x's. Now I'm going to go ahead and do the y. So opposite the y angle is 120. I can set these equal to each other. And if you notice, there's nothing to solve here. This is my final answer. All right. 2 more properties. Okay, so let's go ahead and talk about, if you have a parallelogram, then consecutive angles are what we call supplementary. that just means they equal up or add up to 180. That's what supplementary means. So consecutive angles are angles that are next to each other. For example, angle P is consecutive with angle Q. Q is consecutive with R. R is consecutive with S. S is consecutive with P. And it also goes in reverse. R is consecutive with Q. So angles that kind of go in order are consecutive. Okay? So, in this particular example, we have measure of angle P plus measure of angle Q. Notice they're next to each other. They should equal 180. Okay, so let's try this property. So our goal is to solve for x in this example. In this example, we have the measure of angle P is this measure, 3x minus 37, and measure of angle S is this measure. Since this is a parallelogram and these angles are next to each other, they're consecutive, we can add them up and put them equal to 180. So let's do that. So I now know angle P plus angle S is equal to 180, and angle P is 3x minus 37 plus angle S, which is x plus 17, should equal 180. All right, so now we just solve for x, so I'm going to combine like terms, 3x plus x, that gives me 4x, and then negative 37 plus positive 17, that's going to give me minus 20. Bring down the 180. Add 20 to both sides to solve for x. 4x is going to equal 200, and then divide everything by 4. And you get x equal to 50. Okay, so that's how you use consecutive angles in a parallelogram. All right. Last but not least, it says if a quadrilateral is a parallelogram, then its diagonals bisect each other. And what bisects means is cuts into equal lines or line segments. Okay? So what that means is, if we look at our drawing here, we have this diagonal, PR is a diagonal, this entire line. As this line crosses through it, we now know that this piece, PM, is the same as RM. They are equal because it got cut into an equal piece. So PM and RM are the same. They could be put equal to each other. Same goes for this diagonal. SQ is a diagonal, but it got sliced into equal pieces by PR, so that means SM and QM are the same. Okay? So when you have a parallelogram and the diagonals cross, we now know that it creates two sets of equal measures. So let's try this in our example. Our example here, we have diagonals in a parallelogram. Because that happens, I can now say that 6x and 72 are equal to each other. They have to be the same measure because they've been bisected. So I can now say 6x is equal to 72. Because of that, I can now solve. So I'm going to divide by 6. x is going to equal 12. Now we're trying to solve for y. So because y is the diagonal, it's been bisected. So that means 50 is equal to 5y. So I'll set that up. 50 equal to 5y. We can now solve for y. We're going to divide by 5. And y is going to equal 10. So those are the properties of parallelograms and how to use them.